3, last example, example 7. This one's a little easier than example 6. It wants us to show that the Maclaurin series for cosine of x, which we remember is even powers, minus x to the 6th over 6 factorial, all the way out to summation k, I keep trying to write n because it's n in another book I teach out of, negative 1 to the k. To get the alternating, I need even powers, and then it was 2k factorial. Want to show that it converges, same deal, negative infinity to infinity. So we look at it and we say, all right, we need the remainder. The remainder, regardless of what I do, is going to be the next derivative at some c, n plus 1 factorial x to the n plus 1. But now think about the function. The function is cosine. The cosine curve, no matter how many derivatives you take, it's either going to be a sine or a cosine. And the cosine and the sine curve have a boundary. They can only oscillate between negative 1 and 1. So the biggest this derivative will ever be is going to be 1. So I'm going to say, well, this is definitely going to be less than 1 times x to the n plus 1 over n plus 1 factorial. So this whole piece up here, this guy right here, is going to turn into 1 because that's the biggest that the derivative will ever be. So now if we look at this, again, we're looking at x to a power over a number factorial, and factorial always outstrips it. So when we take the limit as n goes to infinity, and I'm just going to write the absolute value on the x because it doesn't need to be anywhere else. It is going to head to 0. So again, if the remainder is 0, then the series that I'm generating is converging for all x. And that concludes section 11.3. There is, in the textbook at the end of this section, it's on page 710, a list of all the common power series that we use all the time. We have developed a bunch of these, almost all of them actually, in the past few sections. So that will help you out. Things to notice about this is the sine curve is always the odd, because if you graph a sine function, it is an odd function. Cosine curve always has evens. It is an even function, so that makes sense. E to the x, and those both alternate. E to the x has all of the terms in it, but there's no altering, no alternating between negative and positive. All three of those are convergent everywhere. The rest of them have some little boundaries on them, except for the hyperbolics. They're different too. And the last one we just did was the 1 plus x to the p, the binomial series. So we've covered almost every single one of those. That is a good table to have handy when you're working on assignments, because you can always take a sequence and adjust it like we did in example, which one was it? In this section. Yeah, example 3, where we had to come up with other generations for e to the x. So it helps if you have that handy. So this concludes section 11.3.